Hello students, Mr. Quinteros here. You finally get to see my face without a mask on. Now, this video is a summary video for Mr. Jong's geometry class, and we will be doing these regularly to help you master geometry. For me, in high school, geometry was tough, but I was able to get through it with practice and asking for help, and I would recommend you do the same. Now, Mr. Jong in week 2 covered reflections and reflective symmetry. Now, you should understand that a reflection is when a graph or picture can be folded so that both sides of the fold are perfectly matched. And if you take a look at the shape here in the screen, if it were to be folded, it is a perfect match. It is said to have reflective symmetry, and think of this gray area as a mirror, and it's reflecting the other side. Now, the line where the fold would be is called the line of symmetry. So that is called the line of symmetry. Now, if we were to look at a person's face, that's also symmetrical. Just drawing a line down the middle will help you notice that it's reflective. So some shapes have more than one line of symmetry. And if you look at these shapes, they have more than one line except for two. The kite only has one line of symmetry, and this shape right here has no line of symmetry. Now, lines of symmetry might be vertical, horizontal, or some type of diagonal. And if you look at the square, it has a vertical, horizontal, and two diagonal symmetry lines. Now, you should be able to identify whether a figure has reflective symmetry or where the lines of symmetry are. And any shape that can be folded will have a line of symmetry, except for odd shapes like this one in particular. Now, in class, you were able to create your own figures that have symmetry, and this student was able to do that. And as you can see in this image, there's a vertical, horizontal, and a diagonal, because if you fold diagonally, the colors will match. In week 3, Mr. Jong covered area and perimeter, and the perimeter of a two-dimensional figure is the distance around its exterior and the total length of the boundary. And so if you look at the image on the screen, you see that, right? You see the exterior and the total length comes out to 23 units for the perimeter. Now, the area indicates the number of square units needed to fill up a region. So if we were to look at a rectangle, the area is computed by multiplying the length and width. So in this rectangle, the length is 5 units and the width is 3 units, which comes out to 15 square units. Now, you worked on identifying patterns of growth with differently shaped figures. This example is set 3. And you should have been able to identify how this growth affects the area and perimeter of each shape. So for each of the figures, the pattern of growth can be seen through the shaded and unshaded regions on the shape. And they're all growing visually by adding a row and column to the outside of each section. Now, this creates a unique pattern where the area can be calculated by taking the figure number and squaring it to find the area of a single shaded, unshaded region. So if you square 2, it equals to 4 for one region. Then you can multiply this value by the total number of sections in the figure to find the area of the total figure. So 4 times 5 equals 20. And then the perimeter was found by taking the original perimeter number, and multiplying that by the figure number. So the original perimeter number was 12. 12 times 2 equals 24. Now, this student did exactly that with the next figure, figure 4, figure 5. They found the area to be 80 and the perimeter to be 48. So 12 times 4 is 48. And if you multiply 4, right, you square 4, it equals 16. And 16 times 5 equals to 80. You then analyze the pattern in a table and a graph in order to create a generic rule for identifying the area and perimeter of any figure within that set. That's it for the video for today. Hopefully that was helpful. We'll continue these videos. See you next week.